Okay, honors chemistry people, today it's time to learn about significant figures. So I want to go over the rules again because it's kind of a new concept. You haven't done significant figures unless you've done physics before, and I don't think most of you have done physics before. So let's go over the rules again to make sure that we can cement them in our head. So rule number 1, non-zero numbers right here are always significant. Okay, so 72.3 will have 3 significant figures. Rule number 2, all final zeros to the right of the non-zero numbers with a decimal are significant. Okay, so make sure that the zeros are to the right of a non-zero number with a decimal in the number somewhere. Those are always going to be significant. If the zeros are to the left of the decimal of the non-zero numbers, they're not significant. They're just placeholders. Okay, number 3, any zero between significant figures or non-zero numbers is going to be significant. So 60.5 will have 3 significant digits. Number 4, placeholder zeros are not significant. So the way to do that is to rewrite the number in scientific notation. Okay, so for example, on this first one, I have 0.0253. That 0, even though that it is with a number with a decimal point, since it's to the left of the non-zero numbers, it is a placeholder number. It is not significant. So there will be 3 significant digits there, the 2, the 5, and the 3. If I have a number that has zeros at the end, and there is no decimal place there, like this 4,320, if there's no decimal point there, that means that 0 at the end is just a placeholder. So it will be not significant. So I have 4, the 3, and the 2 are all significant. Okay? Rule number 5, counting numbers and defined constants have an infinite number of significant figures. So if I have a counting number, like I can actually count actual items, that has infinite amount of significant figures. If I have a definition, like 1 meter is 100 centimeters, that is a definition that will have infinite number of significant figures. Okay, so the best way to learn is practice. So let's practice on a couple of these. I want you to pause this video, take a minute, fill in how many significant figures you think each of these numbers have, and we'll check in just a little bit. So see you in a bit. Okay, have you figured it out? So A, I've got 29.43. I've got no zeros in here at all. So all of these are significant digits. I've got 4 digits here. 507.2, notice the zeros in between non-zero numbers. So we have 4 significant digits here as well. Okay, here is where we get a little bit tricky. These zeros are to the left of the non-zero numbers. That means they're just placeholders. So just the 3 and the 4 here are significant. So I only have 2 digits that are significant here. All right, on D, notice I have no decimal point on these zeros. So that means these zeros are just placeholders. The 2, the 4, and the 5 are the significant numbers. So I have 3 significant digits there. Here, I've got both things going on. I've got a decimal with numbers or zeros to the left. I've also got a 0 to the right. So we've got 2 different ways of looking at zeros. These numbers, these zeros to the left are just placeholders. So, but the 0 to the right is actually significant. So 8, 7, 6, and 0 are all significant numbers. So I will have 4 significant digits there. In F, I've got a decimal point. And that decimal point makes the zeros to the right after the non-zero numbers significant. So I have 3, 6, plus 2 more. I have 8 digits in that number that are significant. Okay, and 3 eggs. I can count those eggs. 1, 2, 3. That is a counting number. So that means I will have an infinite number of significant figures. Okay? So let's practice how we're going to round things. We're going to use normal rounding numbers. So if I'm going to use 4 significant digits, I'm going to count over 1, 2, 3, 4. I look next door to the right to tell me whether I leave it alone or I round up. So that 1 tells me to leave it alone. So I'm going to report this as 84.79 kilograms. Okay? Take a minute, work on the rest of them, and we'll check in just a sec. Okay, so you ready? So 1, 2, 3, 4. I'm going to look at that 3. That 3 tells me to leave it alone. So I am going to report this as 38.45 grams. Okay, how'd you do? Here I have 1, 2, 3, 4. That 6 tells me to round up. So I'm going to report this as 4.936 meters. Okay, remember these zeros to the front before the non-zero numbers are always just placeholders. So I'm going to start counting here. 1, 2, 3, 4. This 8 tells me to round up. So I'm going to write this in scientific notation. 5.482 times 10 to the negative, let's see, 1, 2, 3, 4, negative 4. I had to move that decimal 4 spaces, grams. Okay, here we go. 1, 2, 3, 4. That 5 also tells me to round up. So once again, I'm going to write this in scientific notation. So I'm going to write this as 1.376 times 10. Let's see, I had to move that decimal place. 1, 2, 3, 4, 5 times 10 to the 5th kilograms. Okay, and this one, 1, 2, 3, 4, that 5 tells me to round up. So 2.015 milliliters. How'd you do? All right, so that's how we round using significant figures. It's pretty much the same way that we rounded before. Now we have to do our math a little bit different. So the rules for finding the proper number of significant figures in a calculation. We're going to first do multiplication or division, and we're going to then do addition. So what is the area of a room that measures 8.3 meters by 4.83 meters? Now, if you do this in your math class, you're going to just, the area is always the length times the width, right? So I'm just going to take my calculator and I'm going to type in 8.3 and I'm going to multiply it by 4.83. And your calculator comes up with this. I don't know if you can see that in there, but it comes out with 40.089 meters squared. Okay? Now remember, this number only went to the 10th, and this number only went to the 100th. Do I really know the area, therefore, to the 1000th? Do I really know it that well? Remember, these last digits are estimates. So when we do multiplication, we know we aren't going to know this to that degree of specificity. So what we do is when we look at multiplication and division, we look at how many significant digits the input numbers have. So for example, let's look at this. Let's change my color. The 8.3 has 2 significant digits. The 4.83 has 3 significant digits. So when we multiply or divide, we always hold our answer to the input number that has the least amount of digits. So this one has 2 digits. I can only report 2 digits. So that means 40, 1, 2, and then 0. That 0 tells me to leave it alone. So there's two ways that I can report this and keep my significant digits at 2. I can write this as 4.0 times 10 to the 1 meters squared, or I can write this as 4D with a decimal by it, meters squared. Both of these answers give me 2 significant digits in my answer, and I can only report 2 because my least number has 2 digits. Okay, let's do another practice one. Okay, what is the density of a metal object that has a mass of 9.42 grams and a volume of 1.2 centimeters cubed? So density is the mass divided by volume. So I'm going to take the mass, 9.42 grams, and I'm going to divide it by the volume, 1.2 centimeters cubed. I'm going to get my trusty calculator out. 9.42 divided by 1.2, I get 7.85 grams per centimeter cubed. Now, we need to look at the amount of digits that we have. I've got 3 digits with this number, and I've got 2 digits with this number. That means I can only use 2 digits to report my answer. So I'm going to count over 2, 1, 2. That 5 tells me to go up, to round up. So I'm going to report this as 7.9 grams per centimeter cubed. Okay? So remember, when we are multiplying and dividing, we are always looking at the numbers that we are using as our input numbers. And the number that has the least amount of sig figs is what we are going to be able to report. So example, if I have a number that has 3 sig figs and another number that has 4, I'm only going to be able to report 3. So we're always looking for the number that has the least amount of sig figs in our input numbers, and that's the amount of digits that we can report on our answer. Okay? Addition is a little bit different. Addition, we are always looking at place value. And we have to take the least accurate place value. Is where we are going to look at when we add or subtract. So let's do our example here. Add the following measurements and give us the answer. So if I do 12.52 plus 8, let's see, I should probably write this out. It will make it a little bit easier for you to see. 12.52, I have 8, and I have 72.3. And if I add those all up, I would get a 2, and 5 plus 3 is 8. I've got 12, I'm going to carry the 1. I've got 82.82 centimeters. And at that point, your math teacher would be like, hurrah, you're awesome. Not so much here. So let's look at this. Our least, remember, the last digit is always an estimate. So this is an estimate, this is an estimate, and this is an estimate. So our ones place here is our least accurate input number. So that means we have an estimation at that ones spot. So I'm going to have to estimate at that one spot. That means I look next door. That 8 tells me to round up. So I am going to call this 83 centimeters. That is all we're going to be able to do because that 8 is going to hold us at that spot. Okay, at the one spot. Let's do another practice. Okay, so if I do this next one, I've got 28.0 centimeters. I've got 23.538 centimeters. And I've got 25.68 centimeters. So I'm going to add this all up. So in the thousandths place, I've only have the 8. In the hundredths place, 3 plus 8 gives me 11. I'm going to carry that 1. 1 plus 5 is 6, plus 6 more is 12. Carry the 1 here. 9 plus 3 is 12, plus 5 more is 17. Carry the 1. Let's see, that will give me 7. And at that point, your math teacher is going, yay! But here we have some issues. We're held to the tenths place. This is an estimate here at the tenths place. This is an estimate at the thousandths place and at the hundredths place. So my estimate, my least accurate estimate is of the tenths place. That means I have to hold my answer to the tenths place. So I'm going to look next door. That 1 tells me to leave it alone. So I'm going to report this at 77.2 centimeters for my length. Okay? All right. So hopefully, wow, I don't know why that jumped around. Hopefully that helps. I'm going to do a couple more examples for you. And then your homework is going to be very much Sig Figs, adding and subtracting with Sig Figs, and dividing and multiplying with Sig Figs. All right, have a great day. We'll see you. Bye.